And welcome to my YouTube channel. Today we are discussing the weekly contest 387 of LeetCode, and we are discussing the last question of it. I'll just remove the solution for now. Distribute elements into two arrays, part 2. So you're given a one indexed array of integers nums of length n. We define a function greater count such that greater count returns the number of elements in AR array that are strictly greater than the value. You need to distribute all the elements of nums between two arrays, array 1 and array 2, using an operations. In the first operation, just append the first element to array 1. In the second operation, append the second number to the array 2. Afterwards, we need to check if the greater count of the current number in array 1 is greater than greater count of the current number in array 2, then we'll append to array 2. Okay, fine. So the question is, first of all, we'll start with suppose we have 2 1 3 3. So what we'll do in our first array, we'll add 2, and in our second array we'll just add 1. So now we'll come to our next element, that is 3. So we'll check in both how many numbers are there that are greater than 3. So there are 0 elements that are greater than 3 in my first array and also in my second array. So what I'll do, so in that case, in both it is equal to 0. So what I'll do, I'll append numSci to the one which is having lesser number of elements, and both have same number of elements, so we'll append it to first array. So it's 3. Now the next element also, yeah, so the next element also is 3. So we'll count how many elements are greater than 3 in both the arrays. In this also it is 0, in this also it is 0. We have to count strictly greater than 0, so greater than 3, so it's 0 and 0. So again it's a tie, so we'll append to the lesser number of element, so we'll append here. Next we'll just concatenate these, and that will give us 2 3 1 3. Let's take another example, that would be 5 14 3 1 and 2. Yeah, so A will have 5, B will have 14. Now the next element is 3. So now 3, A also has one element greater than 3, B also has one element greater than 3, so it's a tie again, and both have same number of elements, so we'll insert it to first one. Now the next element is 1. Now in case of 1, A has two elements greater than 1, B has one element greater than 1, so A wins, so we'll append it to 1. So now we have come to 2. Now 2, A has two elements greater than 2, B has just one, so again A wins. We'll do it like that, and our result would be A plus B, that is 5 5 3 1 and 2 and 14. And so our and the basic brute force approach with this solution could be like, we can just keep on checking while traversing every element. We can just loop through both of these arrays, and we can do a linear search, and we can find out how many numbers are greater than this number, and likewise we can do that, but that would give us a complexity of O(n) square, and that won't be accepted here, as it would be greater than 10 raised to power 9. So as we are going to do a search here, so the best thing if we are looking for something to search would be a binary search in this case. So what our basic intuition would be, like, we'll keep track of two lists or two arrays, that is for sure, and we'll also keep one more array, that would be our sorted A or sorted B. This would contain all the elements of A but in the sorted order, so that we can apply binary search on it and find the number of elements that are greater than that value that we need at that index. So if we again loop through it, we'll just start it from the beginning. This will just have 5, sorted A will have 5, B has 14, this has 14. Okay, so now we come to 3. So we'll apply this binary search on sorted A and sorted B, and we'll search 3. So 3 won't be found. So our binary search would return us the index where it should be placed. So it should give me as 0. When searching for 3, it would give me index as 0. So that means I have to insert it here. So I'll insert it 3 comma 5, but before that it just gives me a index as 0 in this case, and here also it will give me an index as 0. So what that means is now it has given me 0, so I can find out how many elements are greater than what we say, just take it as position 1 is 0, position 2 is 0, position 1 is position of 3 in sorted A, and position of 3 in sorted B. Now that means it should be inserted at position 0. So now we can find out how many greater elements are there greater than 3 in array 1, and that would be my sorted A dot size minus position 1, and that would give me 1. And in such case greater 2 would also give me sorted B dot size minus position 2, that would also give me 1. So that means it is both are giving same, that's a tie, so I should append it to A. So I'll append it to A 3, and here I will append it to the position, that is 0, 3 comma 5. Okay, well and good. So now we come to 1. Now when we come to 1, again I'll apply my binary search and it would give me 0 again. So in both cases it is giving me 0, but now when I do the number of elements greater than 1, this would give me 2, as the array size is 2 now. 2 minus 0 is 2, and this will give me 1. So again this means 1, and I'll put 1 at the index position 1. Now I come to 2. Now when I come to 2, this position 1 would become 1 because it should be inserted here, 1 2 3 and 5, and this would again give me 0. So my this would become sorted A dot size 3 minus 1, that is 2. So 2 elements are greater than 2, and this would give me again 1 minus 1, 1 minus 0, so 1. So that means in this array 2 elements are greater than 2, and this array only 1 element is greater than 2. So again A wins, we'll put 2 and we'll put 2 here. So then at the end we'll just append A and B. So this searching part, instead of doing for O of n, it will take me O of log of n. So that's how we'll save our time complexity, and let's get through the code. So we'll first on see the binary search. Binary search will start with left, right, that is size minus 1. Left is less than right, find the mid. If the value at mid is less than equal to our search value, we'll just do left equal to mid plus 1. So this left, this would return us the next index, or the index where next index of the found value, or the index where value should be placed in actual. Yeah. So what we'll do, we'll loop through, we'll take two lists A and B, and we'll take sorted A and sorted B. We'll insert the first elements, then we'll start from the third element, and we'll do the binary search to find the position of the new value in our sorted list A and in our sorted list B. Now we'll find the greater elements in both. Now that's now this would be simple if and else's. If greater elements are more in first array, we'll append to first, otherwise in the second one, and if they both are equal, in that case we'll just compare the size and we'll add it accordingly. And at the end we'll just take one array and add all the elements of both A and B arrays to our result array. That's it. So we can just submit it once. Works fine. Thank you.